Hey Ann, I'm going to try walk through this a little bit kind of quickly. Hopefully this will work. My computer slows way down, but anyhow, let's look at question one. You don't have to do question one, you have two, but try to do it again and walk through that and how we do that decision rule. If I'm reading your question correctly, I think it's just one part that you're having difficulties with, and hopefully I can address that here. But anyhow, a sample of 40 observations, on, and you can read through that or read along in your book. We come down, and I think the important part is, conduct the following test of hypothesis using the 0.04 significance level. And 0.04 kind of throws us off. We're used to on the t distribution, 0.01, or I think 0.1, or 0.05, and so this one throws us off a little bit, and we have to do a little bit of math. It's simple math, and I kind of like to sometimes do it like this and show it and see what we're looking at. But we know that this one's a two-tailed test, right? Because it is equal to. Anytime we have an equal to, okay, then we know that it's a two-tailed test. So when it's a two-tailed test, then we got to take a look, and for whatever reason I always like to draw them out, and so I draw and forgive my drawing, but I have to, one, do it with a mouse, and two, I'm not a very good drawer anyways. But so I kind of draw it out, and I draw my normal distribution and whatnot, and we normally have a line down that, right, with 50% kind of below the line and 50% above the line, and when we're using the z statistic, that's really what we're looking for, is kind of on one side or the other. And so when we're dealing with a 0.04 significance level, then this is one way to do it. You could divide that by 2 and say 0.02, and then take 50 or 0.50 minus 0.02, and this should be a point, or I'm not, that's divided by, I'm sorry, but you could take the 0.50 then minus 0.02, and you'd come up with 48. Or you can do it this way: 1, because 1's 100%, be doing everything right all the way out here, that goes 100% minus 4% basically equals 96%. Okay, and so we're looking for a 96%, something that appears in here. Okay, but because the z-stats are always based on a half of this, okay, one half or the other, I divide that by 2, and I come up with 0.48. Okay, and 0.48 is our key number, and then finding that is try to minimize this and get to my, okay, finding that using the z table, and that's the one that is on page, I gotta look again, 732. Okay, so that's the one that's on page 732, but I've got it in an Excel format here, and so let me bring that up. This is what it looks like in the back of the book. It's very similar. I don't have the kind of headings up there and whatnot. So how do we find that? Well, as you can see, this starts with 0, and it just keeps getting bigger until basically it comes up to that 0.5, right? 0.4999999, okay, which is basically 5, or 0.5, I'm sorry, okay. And so we're looking for that 0.48 that we've got on both sides of this. And so it goes in order, and so we can cruise down pretty good, but we follow along here, and ooh, there's 0.4793. Well, it's not quite there, and 0.4798 is really not quite there, and 0.4803 is over that, so it would really kind of be in between these two, right? Let me just kind of highlight those if I can, if my machine will work, but we'll try to give those a little bit of a highlight so that hopefully we can maybe see it a little bit better. Okay, so it's kind of in between those, and this one's a little bit closer, and for our work, this is probably rounded off enough. We could interpolate and come up with an even better answer, but this one's probably close enough. So let's use this one. Then I come over here and I say, okay, I have 2.0, and then up here it's 0.05, and so what my z-value is, or for my decision rule, I use 2.05. Okay, and let's write that out, my test statistic. I'm sorry, or not my calculated value, but the value that I use that I'm comparing against is 2.05. 2.05. Okay, and because this is a two-tailed test, it's also minus 2.05. Okay, and what I'm looking for, you know, my hypothesis, my null hypothesis is that I want to have a 96% chance in this case that they're equal. But we always kind of, I don't know, the way I describe it actually is we're always kind of proving the alternate hypothesis instead of actually proving the null hypothesis. And if we prove, you know, the alternate hypothesis, then we reject the null hypothesis. And so we state this then as the decision rule is that we're going to reject the null if, okay, reject null, ooh, I'm not sure, reject, this thing's not working so good. Null. My writing's horrible. Okay, if z is, you know, z is less than minus 2.05, or, I ran out of room there, sorry, should have this all on the same line, or greater than 2.05. Okay, and so again, if I have my little drawing here, my horrible little drawing, you know, my alternate hypothesis is really that I'm going, or my decision rule is that I'm going to reject it if the value that, when I do my calculations, just doing the math, if my value falls outside of here or outside of here, then I reject the null if that's the case. Okay, let's take a quick look at number 2 because it's a single tail, right? It erases my beautiful drawings when I try to get out of here. Again, it's gonna be slow, man. I apologize for it freezing up like this. I wish I could fix it, but I guess until they give me a new computer, I'm stuck with trying to deal with this. Doggone. And it won't even let me out where I could pause the thing. It just sticks right here. And the version that we're using for this BB Express, it's a nice little program to use, but it doesn't allow for much editing afterwards, or it's a little bit difficult to edit afterwards. So I'm sorry, you're going to be stuck kind of looking at a blank screen with me for a second or two. Okay, there we go. So again, if we look at number 2, then it says a sample of 65 observations, la da da. Again, I think we're more concerned about the hypothesis using the 0.08 significance level. But this one's a single tail, right? And so we're going to, if mu sub 1 is less than or equal to is our null hypothesis, right? Okay. or if mu, if mu sub 1, this should be, our alternate hypothesis is that mu sub 1 is greater than, okay, mu 2. Now sometimes getting these a little backwards, that can happen when we make our decision rule. And actually, as long as we do the math correctly and keep our signs in alignment, by that I mean our pluses or minuses or negatives, it'll still give us the same answer, even if we happen to write our decision rule down incorrectly, if that makes sense. So population deviation of 0.75, sample mean, sample mean is 2.59, so conduct. But let's go look up then. So we've got a single, right, of 0.08. Okay, so now we're not doing the dividing. Okay, we're simply saying that, hang on a second here. We're simply saying then, if that's the case and it's a one tail, and remember I've got 0.5 on either half of my, on either half of my little magic finger thing here, and gosh darn, this thing might be slowing it down too, right? Okay, but let's see if I can draw this one then too. Running into something over there. So okay, so I got my middle, and I may end up going down here on the negative side or on the positive side, but just to look, and 0.08 is maybe a little further here, right? Okay, but half is then 0.42, because I've got, in this case, 0.50, and since it's a single tail, I'm just using half of my z minus 0.08, so that's equal to 0.42. Okay, and so then I do the same thing. I come here and I look for there's 0.4192 and 0.4207. So wow, let's kind of take a look at that one. 0.4207, that's actually a little bit closer, and I could argue that it's almost in between. So I could say it's 1.41. 1.40 is pretty close, and it's just about exactly in between. I could also say 1.45, and I'm not going to mark you wrong either way. So it's either 1.40, 1.41, 1.405 you could use actually in that case if you wanted to. Okay, and I doubt that our answer is going to change. If this thing were really, if you came up with a really close, when you did your math and you came up with a really close number, back and technically interpolate this and then come up with a more exacting answer there. But I don't think we need to do that, right? Okay. So hang on, I'm going to pause, I think, here for just 1 second, if I can get this to working. Okay, so when I do a decision rule, then I kind of tend to look at the alternate hypothesis, and our alternate hypothesis is that mu1 is greater than mu2, and so in that case my decision rule is going to be that I'm going to reject the null if my z value, my calculated z value, is greater than that number that I came up with, the 1.40 or 1.41, or somewhere's in that neighborhood, right? And so my decision rule then simply becomes to reject the null if, I'm going to try to write it down here, reject null. This is tough doing this with the mouse. If z is greater than 1.41, let's say. Okay, so I do my calculations then. If my calculated z-value comes out to be more than 1.41, I reject that null hypothesis. Okay, I would accept then basically the alternate hypothesis that the one is actually smaller than the other. I think if I'm looking at that correctly, right? Okay, I hope that answers your question in finding those particular numbers. If not, boy, let me know and we'll try something different. So, till later, I'll sign off.